A disk of mass m and radius r is on a horizontal frictionless table. Two equal and opposite forces, each of magnitude f, act on the disk. The moment of inertia of the disk is half mr squared. What is the angular acceleration of the disk? So a key formula for the rotational motion is like the second Newton's law for usual translational motion. It's what? It's net torque is equal to the moment of inertia times angular acceleration, and actually angular acceleration required, and it is given. It's about the center of this disk. And what about the net torque? Torque by definition, or it's also called the moment of force. It's force multiplied by the shortest of the perpendicular distance, which is a radius here. And since this force rotates or tries to rotate in clockwise and is also in clockwise, the net torque is equal to the sum of torques produced by this force and this. And so the moment of force or torque for this force, it's F times r, and this torque is also F times r. So the net torque is 2Fr, and this is equal to the moment of inertia, it's a half mr squared and alpha. And we need just solve for alpha, and we can see that alpha becomes 4F divided by mr. So it's D. The next. A cylinder of mass m and radius r rotates at constant angular speed omega with about an axis through its center. The rotational kinetic energy of the cylinder is K. The moment of inertia of the cylinder is half mr squared. A second cylinder has mass 2m, radius 2r, and rotates with angular speed 2 omega. What is the rotational kinetic energy of the second cylinder? So since it's about the rotational kinetic energy, we need a formula, and the formula says that kinetic energy, rotational kinetic energy, is equal to what? The moment of inertia, omega squared over 2. And for the first cylinder, kinetic energy is K, and the moment of inertia is a half mr squared omega squared and divided by 2. And for the second kinetic energy is required, and it is equal to also the moment of inertia, but it's in general mass of a cylinder and radius squared, but for this mass is 2 times larger, so it becomes a half, and 2m, and radius squared, so it's 2r squared, and omega for the second it's 2 times larger, so it's 2 omega and also squared, and over 2. And it becomes I keep this 2 times 2, but it arises 2 times 4 times 4, so it's 32 mr squared omega squared, and we can see that this is K, the kinetic energy for the first. So it becomes 32K. So it's C. And that's all for this question.